In this video, we are going to review Lewis structures for both ionic and covalent compounds. To start, for ionic compounds, we want to, in this example, draw the Lewis structure for magnesium chloride. So recall, we need to draw the Lewis structures for each of the elements individually. So magnesium has 2 valence electrons, and then it's going to combine with 2 chlorines, each with 7 valence electrons. And what we want to do is we want to show an arrow to show where the electrons are donated from and where they are donated to. So 1 electron from magnesium is donated to one of the chlorines, and 1 electron, the other electron from the magnesium, is donated to the other chlorine. That is going to create a magnesium 2 plus ion and 2 chlorine ions with a -1 charge. Now we always just by convention show the electrons around the chlorine ion, but we don't show them for the magnesium ion. And I'm going to put in 2 in front here because we have 2 chlorine ions. Lewis structures for covalent compounds are a little bit more complicated, and there are several steps that we need to follow in order to draw a complete Lewis structure. The first is that we want to determine the total number of valence electrons. We then want to write the skeleton structure of the molecule. Then we want to start placing electrons, and we're going to first use 2 electrons to form each bond between atoms, and then we are going to try and satisfy the octets of the atoms that are on the outside by distributing the remaining electrons as non-bonding electrons. And then once we've done that, we're going to try to satisfy the octet of the central atom by distributing the remaining electrons as non-bonding. So let's take a look at some examples. In the first one, we want to draw the chlorate ion. As a general rule, the element in the compound with the lowest number of atoms goes in the middle of the molecule. So for this one, there's 1 chlorine, 3 oxygen, so the chlorine is going to go in the middle. And we're going to draw the 3 oxygens around it. Now we need to determine the total number of valence electrons. For chlorine, chlorine has 7. Each oxygen has 6 valence electrons. So we have 3 times 6, or we have 18 electrons. And the -1 charge means we have 1 extra electron. So in total, we've got 26 electrons. Okay, so there should be 26 electrons in our final structure. We're going to use 2 electrons for each bond first. You can represent that by a line. So a line means that we have 2 electrons. So 2, 4, 6. We still need to place 20 electrons. We're going to start by putting those around the outer atoms. So if we do that, then we will have used up, whoops, running out of room there. We will have used up 24 electrons. We have 2 remaining, so we want to take a look at our central atom, and our central atom only has 6 electrons surrounding it, so we can put 2 more on it to create a stable octet. And then because this is a charged molecule, we're going to use square brackets and indicate the charge outside the brackets. If there are multiple different atoms, the least electronegative element is in the center of the molecule. So because there's 1 sulfur and 1 oxygen, we need to decide which one goes in the center. Looking at our electronegativity rules, we know that sulfur is less electronegative than oxygen, so sulfur is going to go in the middle. and all of the other types of atoms are going to surround the sulfur. Now we need to figure out the total number of valence electrons. Oxygen has 6, sulfur has 6, and we have 2 chlorines each with 7 valence electrons. So if we total this up, we're going to get 12 plus 14, which equals to, 26 electrons. So again, 2 between each bond, that's 6 total. We're going to add around the outer atoms. And this one's really similar to the last example we did. That uses up 24 electrons. The remaining 2 go on the sulfur to complete sulfur's octet. Now sometimes molecules can contain too many or not enough electrons, so we want to go through an example of each, starting off with too few electrons. The way that we're going to get stable structures is by sharing more electrons to form either double or triple bonds. A good little hint to tell you that an element is going to form a double or triple bond is if you've got a carbon, nitrogen, oxygen, phosphorus, or sulfur. So let's do the Lewis structure for formaldehyde. Now looking at this, carbon and oxygen, there's both only one of them, but carbon is the least electronegative, so it's going to go in the center, and then the oxygen and the hydrogen surround it. Calculating the total number of valence electrons, oxygen has 6, carbon has 4, and each hydrogen has 1, so that's 2 total. So we've got 12 electrons total for our structure. Let's create those bonds first. So that uses up 6. Now hydrogen has a full valence already. Remember, they only need 2 to fill their valence. So we'll fill oxygen. Okay, and if we take a step back and look at this, we've now used 12 electrons in our structure. So we don't have any more to put on carbon, but carbon's octet is not satisfied yet. So what we want to do is share another pair of electrons between the oxygen and the carbon in order to satisfy the octet of the carbon. So that's going to give us a final structure where we have a double bond between carbon and oxygen, single bonds between the carbon and hydrogen, and 2 pairs of electrons on the oxygen. Sometimes you can have too many electrons. When that happens, the valence shell of the central atom can expand. And we're going to go into why this can happen a little bit later in this course. So let's consider sulfur tetrafluoride. Sulfur goes in the center, the 4 fluorines surround it. In terms of total valence electrons, sulfur is 6, and then we've got 4 sulfurs, each with 7. So that's 28 total, plus 6 gives us 34 electrons. So if we go around and put 2 between each bonds, now I'm going to show you a little cheat here. You can also represent 2 electrons with lines around the outer atoms too. I like to do this when there's lots of them so that I'm not drawing all the little dots. And if we look at our structure, we've used 8, 16, 24, 32 electrons. We still have 2 electrons to place, so the valence shell of the central atom is actually going to expand. And we're going to put them on the sulfur just on the side here. So sulfur actually has 10 electrons surrounding it. There's also like some really weird ones. Boron trifluoride, it's just weird. Boron trifluoride has 24 valence electrons. If we do the Lewis structure for it, Okay, we fill the outer shell for each of those. And if we count up the electrons, we've used 24. Boron only has 6 around it, but it's okay with this. And we're going to explain again, as I said, why this happens. And we're going to explain it using the quantum model of the atom.